The explosion tore through the lab at 3 a.m. Fritz Haber stood in the wreckage, covered in soot, iron fragments still ringing across the stone floor. And then he laughed, because he knew. One more adjustment, and he'd have it. Sometime in the early 1900s, the math became undeniable. The Earth was running out of the ability to feed itself. Not running low, running out. Plants need nitrogen to grow, but plants cannot absorb it from the air. They can only pull it from the soil. And by the late 1800s, after generations of farming the same fields, the soil across Europe and America was exhausted. The only fix was fertilizer, and the world's fertilizer supply, mostly harvested from seabird droppings on remote Pacific islands, which sounds absurd until you realize nations were going to war over it, was almost gone. In 1898, the British scientist William Crookes stood before the most prestigious scientific body in the world and said plainly, "England and all civilized nations stand in deadly peril, not from invasion, not from plague, from the inability to grow food." Every scientist who looked at the numbers reached the same conclusion. At current population growth, within 30 to 40 years, the Earth simply could not feed everyone alive on it. There was no solution. Every chemist in the world knew it, except one. Fritz Haber was not an easy man to like. He was arrogant, relentless, and had already abandoned his Jewish faith in an attempt to be accepted as fully German, a decision that would return to destroy him in ways he couldn't yet imagine. But in 1904, he became obsessed with what every other chemist had already declared impossible: pulling nitrogen directly from the air and forcing it to bond into ammonia, the compound that could become fertilizer, the compound that could feed the world. The problem was the nitrogen molecule itself. It is one of the most stable structures in nature. Breaking it apart requires ferocious heat, crushing pressure, and a catalyst that, as of 1904, nobody had identified. The great Wilhelm Ostwald, who would later win the Nobel Prize, had already attempted it and walked away. He called it commercially unviable. He was being polite. He meant impossible. Haber didn't care. On a Tuesday night in November 1907, at roughly 2 a.m., Haber was alone in the lab. His assistant had gone home hours ago. His wife, Clara, one of the first women in Germany to earn a doctorate in chemistry, had stopped asking when he'd be back for dinner. The iron pressure chamber in front of him was running at 180 atmospheres, nearly 200 times the pressure of the air outside. The temperature inside was climbing toward 500 degrees Celsius. The needle on the pressure gauge was nudging past the red line. He should have shut it down. He had a protocol. He'd written the protocol himself. He stood there and watched the needle instead. It held for 11 seconds. Then the chamber detonated. The blast threw him across the room. He hit the far wall and slid to the floor. For a moment, there was just ringing, a high, clean tone, and the smell of ammonia and hot iron. He lay there for a few seconds. Then he got up, pulled his notebook from his coat pocket, and wrote down exactly what had gone wrong. This happened not once, not twice. Clara would later tell a colleague she had lost count of how many times she heard the sound of an explosion from the direction of the university and waited to find out if her husband was still alive. He kept going. New catalysts, new chamber designs, iron, then osmium, then uranium, every failure generating data, every explosion a narrowing of the problem. And then came July 2nd, 1909. It was early morning. Haber and his assistant, Robert Lerossignol, had been running the apparatus since before dawn. New catalyst, refined pressure curve, everything dialed to the tolerances they'd spent 2 years calculating. The chamber held, the temperature held, the pressure gauge, the needle that had torn through its red line and detonated everything over and over for years, sat steady. And then, from the outlet valve at the base of the iron chamber, slow, almost reluctant, a single drop appeared. Then another. Ammonia, liquid ammonia, synthesized from nothing but nitrogen and hydrogen, from air. Roussillon said nothing. Haber said nothing. They stood in that lab and watched it drip. Haber reached out and put 2 fingers under the stream, felt the cold of it against his skin, looked at his hand. According to people who knew him, Fritz Haber was not a man given to visible emotion. He was controlled, precise, withholding. He wept. He stood in that lab at the age of 40 with ammonia on his fingers and the smell of hot iron in the air, and he wept because he understood more completely than anyone alive in that moment what he was holding. This drip, this tiny, cold, insignificant drip, was food. Infinite food. Food grown not from exhausted soil or mined guano or the slow death of the Earth's fertility, but from the air itself.
Within 3 years, the chemist Carl Bosch had scaled Haber's dripping tabletop apparatus into industrial factories the size of small cities. Within a generation, those factories were feeding hundreds of millions of people who would otherwise have starved. Today, 8 billion people are alive on this planet. Scientists estimate that roughly half the nitrogen atoms in every human body on Earth passed through a Haber-Bosch reactor at some point. Think about that for a moment. Half the atoms that make you up, your blood, your muscle, your brain, were once processed by a machine that exists because Fritz Haber refused to accept that the problem was impossible. He didn't just feed the world. He is why most of the world exists. By any measure, by any honest accounting of human history, Fritz Haber should be the most celebrated scientist who ever lived. So why have most people never heard his name? Here's the part they don't put in the textbooks. The same year the Haber-Bosch process went into mass production, World War I began, and Fritz Haber handed his process directly to the German military. The ammonia that was supposed to become fertilizer became, instead, the key ingredient in explosives. An estimated 1 million additional deaths directly attributable to the fact that Germany could keep making bullets because Fritz Haber had solved nitrogen. But he didn't stop there. Fritz Haber personally supervised the first large-scale chemical weapons attack in history. On April 22, 1915, in Ypres, Belgium, German forces released 168 tons of chlorine gas across a 4-mile front. The wind carried it into the Allied trenches. Soldiers described a yellow-green cloud moving toward them. They had no idea what it was. Over 1,000 men died in minutes. Thousands more were blinded or permanently lung damaged. Fritz Haber stood behind the lines and watched. He called it a higher form of killing. He believed it would shorten the war and therefore save lives overall. His wife Clara disagreed. When Haber returned home after Ypres, decorated, celebrated by the German military, Clara confronted him. She called his work a perversion of science, a war crime. She begged him not to go back. He had orders for the Eastern Front the next morning. He went anyway. That night, Clara went into the garden. She took Fritz's military pistol and she shot herself. Her 12-year-old son Hermann ran out at the sound of the gunshot and held her as she died. Fritz Haber left for the Eastern Front the next morning. He won the Nobel Prize in Chemistry in 1918 for the fertilizer process. The committee that awarded it knew about Ypres. They gave it anyway. The French chemist Victor Grignard, himself a Nobel laureate, publicly refused to attend the ceremony in protest. He wrote that handing a prize to a man who had personally engineered the gassing of soldiers was an act the scientific community would spend decades trying to explain. He wasn't wrong. Haber accepted the award anyway. When the Nazis rose to power, Haber, who had converted from Judaism, who had given everything to Germany, who had won Germany a Nobel Prize and arguably kept their army fighting for 2 extra years, was dismissed from his university post because he was Jewish. The man who had done more for the German state than almost any scientist alive was expelled from it by a racial law he had spent his entire career trying to make himself immune to. He fled to England. Cambridge offered him a position out of pity. He arrived broken, ill, and largely silent. Former colleagues described a man who seemed to have finally run out of momentum, as if the machine that had driven him through decades of explosions and obsession and moral compromise had simply stopped. He died of heart failure in Basel, Switzerland on January 29, 1934. I've spent a long time sitting with this story, reading about him, trying to find the clean verdict, the right answer. There isn't one. So I'll leave you with the only question that matters. Knowing everything that came after, would you have let that ammonia drip? Drop your answer below. I'll be reading every single one.